All right, we're back for another video. Now we're getting into El Nino. So, here's the short of it, or what I'm calling an elevator pitch. El Nino is considered a coupled phenomenon. Coupled meaning two parts to it. The two players here in this couple are going to be the atmosphere and the ocean. So we're talking about things that happen during El Nino are changes that occur in both the atmosphere and in the ocean. So let's talk about those changes. Here we go. The details. First and foremost, where does El Nino occur? It occurs in the tropical Pacific Ocean, or you can call it the equatorial Pacific Ocean. College Board does want you to make this distinction. You can't just say El Nino happens in the Pacific Ocean, because technically speaking, the atmospheric changes are beginning in the tropical or equatorial Pacific Ocean. So we want to use those terms and not just say Pacific, because we could be talking the extreme South Pacific down near Antarctica, which is technically Southern Ocean. That's not where El Nino originates. So the equatorial Pacific Ocean, how often it occurs? It's anyone's guess, really. Every 3 to 7 years, give or take. But that's not exact either. So I just put every few years, you know. So we've got where it is, when it happens-ish. So let's talk about what happens during El Nino. So you have to kind of compare normal conditions, which I had in the first video, to El Nino conditions. So when there is an El Nino happening, the first thing that happens is the trade winds, which are those winds that are blowing from 30 degrees towards the equator, 30 degrees latitude. And they normally blow from east to west, which is what I showed you in that first video. The trade winds are blowing from east to west under normal conditions, but during El Nino conditions, those trade winds begin to weaken. Nobody's really sure why the trade winds weaken, but they are beginning to weaken. Some websites, some textbooks you might come across will say that the trade winds reverse direction. I'm not going to say that. I'm just going to use the term weaken, because I feel like not necessarily accurate to say that the trade winds reverse direction. So the trade winds weaken. That means there's not as much wind blowing from east to west in the tropical Pacific Ocean. And this is important, and I'll tell you why. The reason why this is important is because that warm water pool that I had mentioned before, that's over in the western Pacific, western tropical Pacific, near Australia and Papua New Guinea, that warm water pool was kind of like being held up like a dam by those trade winds. The winds were pushing all the water to the west and kind of keeping the water in the western tropical Pacific. Like the sea level in the western tropical Pacific compared to the eastern tropical Pacific, sea level in the west is actually significantly higher because the winds are pushing a lot of water in that direction. But if the winds are weakening, then all that water that's kind of piled up in the western tropical Pacific near Australia and Papua New Guinea, that water begins to slowly go back across the tropical Pacific towards the east, because you've got a lot of water in the west, you've got less water in the east. Nature wants things to be in equilibrium, so the water is going to flow from the western Pacific towards the eastern Pacific. So that warm water is traveling across the equator. It's getting even warmer as it's traveling across the equator. And what that warm water does, once it reaches near South America, that warm water, which is on the surface, because warm water is less dense, so it stays up high, that warm water blocks the upwelling current. Remember, an upwelling current brings cold, nutrient-rich water from the depths of the ocean towards the surface. And there are upwelling currents off the coast of South America that are being blocked by this warm water that has moved across the tropical Pacific Ocean. And now that warm water is blocking the upwelling. So, what does that mean? Well, if the upwelling is being blocked, that I don't have that on this slide, whoops. If the upwelling is being blocked, that's going to affect food webs off the coast of South America. The other thing I have on this slide, I guess I'll get back to the food webs. The other thing I have on this slide is that, now we've got all this warm water in around places like Peru and Ecuador, which means more warm water equals more evaporation, which means more precipitation. So places that don't normally have huge amounts of rainfall, during an El Nino, they get more rainfall because there is more warm water off the coast of Ecuador and Peru. I will always use those as examples. And that warm water means there's going to be more evaporation, which means more precipitation. So to kind of illustrate what it is I'm talking about here, top map is showing normal conditions. So under normal conditions, the winds and therefore the currents are moving from the eastern tropical Pacific to the western tropical Pacific. During an El Nino, the warm water goes across from the west Pacific to the eastern Pacific. That warm water pool also blocks that cold upwelling current. This is a really bad map showing the same thing. This is a slightly better map. I had this similar map in the first video. So again, showing everything that's happening. Warm water is moving from the western tropical Pacific to the eastern tropical Pacific. There is in the atmosphere more storms because you've got more warm water. Notice here the thermocline is now deeper in the water. Under normal conditions, the thermocline comes up to the surface. But during an El Nino, the thermocline is deeper because the hot water is sitting, or warm water is on top of it. So that is what is blocking the upwelling current from reaching the surface and feeding phytoplankton and everything else in the food chain. This is just a little GIF that's showing that pool of warm water starting in the western tropical Pacific Ocean and moving into the eastern tropical Pacific Ocean. This is a video that I'm going to skip. So some impacts of El Nino around the world. I know we're focusing on, the tropical Pacific, but look at the map. There's changes everywhere. Why are there changes all over the planet if this is a phenomenon that happens around the equator in the Pacific Ocean? Because remember, everything is connected together. The atmosphere is all connected, the oceans are all connected. So if we have a change in one place, we're going to have changes in lots of places. So some impacts or effects of El Nino, I've already mentioned fewer surface nutrients because there's less upwelling, which means you're going to have less photosynthesis, which is known as primary productivity. Your phytoplankton aren't going to get as many nutrients as they need, so photosynthesis is going to go down, which means there's going to be fewer phytoplankton, which means there's going to be fewer of everything that eats the phytoplankton, like fish and seabirds and seals and whales. All of that is affected by phytoplankton populations. The weather around the planet changes, as you can see in this map. We tend to focus on conditions in South America, like Peru and Ecuador, where it's wetter and warmer than usual. So more rainfall means more flooding in places like Peru and Ecuador. In the United States, where we are in the southeastern United States, they tend to have a much wetter time when El Nino is happening. The northwestern United States and the northeast is warmer than usual. Australia, parts of Indonesia, drier than usual. Like, there's changes everywhere because everything is connected together. This is showing the same things. Again, rainfall in the southeastern and south United States, warmer in the northwest and northeast. Again, looking at Peru and Ecuador, much more rainfall than normal. And then Indonesia, New Guinea, Northern Australia, much drier than normal. That's usually what College Board asks about, are those locations. I've never seen them ask about Africa. El Nino affects us here in Florida. because it actually reduces hurricane formation in the Atlantic Ocean. You don't need to know the details of this, but again, just kind of emphasizing the fact that everything is connected together. Changes in the atmosphere in the tropical Pacific Ocean bring about changes to the Atlantic Ocean, and it makes it more difficult for hurricanes to form in the Atlantic Ocean during an El Nino. So we like El Ninos here in Florida because we have fewer hurricanes. And so this is just comparing normal conditions versus El Nino conditions. Great idea to take a screenshot of that. La Nina. La Nina is kind of just like I wrote here. It exacerbates normal conditions. It makes whatever is normal, makes it a little bit more so. So like if an area, let's say around New Guinea, already experiences a decent amount of rain during normal conditions, I don't have normal on here, then during La Nina, it's going to get even rainier. Or a place that is already hot and dry during normal conditions, it's going to be even hotter and drier during La Nina conditions. Here's some details. Like, I don't think you need to write them all down and memorize them, but notice, like, I'm saying colder, warmer, wetter. It's just making whatever normal conditions are a little bit worse. We here in South Florida do not like La Nina, at least most of us don't, because it increases the chances of hurricanes forming in the Atlantic Ocean. So that's everything with El Nino. So to kind of wrap things up, you have to have an understanding of what's going on with the wind and the ocean currents. You have to be able to identify normal conditions and El Nino conditions or La Nina conditions. So to finish things off, look at this map and tell me if an El Nino or a La Nina is occurring. To kind of orient yourself in the map, over on the right side in the dark gray, that's Central America, South America over here, Australia in the lower left, New Guinea, and then everything in the middle is Pacific Ocean. So this map is showing us that El Nino is happening. How do we know? You've got all this warm water off the coast of South America. Under normal conditions, there's not that much warm water. Under La Nina conditions, there's not warm water off the coast of South America. And what this is showing is just temperature anomalies, changes from normal. Looking at this picture here, again, over in the upper right, you've got Mexico and Central America, South America here, Australia, New Guinea. So in this particular map, we are seeing La Nina. How do we know? Because you've got cooler water extending across the whole Pacific Ocean, even towards the western Pacific. That's how we know it's a La Nina. So that's pretty much everything with regards to El Nino and La Nina. Of course, if you have any questions, please reach out and ask me. I am here for you. So that's all for now. Bye.